Hi everybody, welcome to Stats Online. We are now in lesson 2-6, which is talking all about residual plots, and we are going to assess a regression model today. So you are going to be able to use residual plot to determine if the regression model is appropriate, and you're also going to be able to interpret R squared. All right, so let's get started. So we have learned so far how to calculate the least squares regression line. And it's important to think about that line and is it a good fit for our data? So we ask ourselves these two questions. Is a line a right model to use? Is that line? Or would a curved line be better? If the line is straight and it's right to use, how well does it make predictions? So we can use residuals to assess whether a regression model is appropriate by making a residual plot. So a residual plot is a scatter plot that plots the residuals on the y-axis and the explanatory variable on the x-axis. So here is a scatter plot on the left that shows the relationship between the Super Bowl number, so this is like Super Bowl number 5, Super Bowl number 10, along with the cost of a 30-second commercial and for the years 1967 to 2013. And so on our y-axis, you can see this is the cost of a 30-second commercial. If you take a look at our data looks like it's starting to curve, kind of appears that in a short amount of time, the amount of money it is on that commercial gets really high, really fast. So this is our least squares regression line, and you look at it and say, I don't think that this is the best fit for our data. And maybe a curved would be better. And if you're thinking I don't really think that that least squares regression line is appropriate for our data, we can make a residual plot. So a residual plot is on the right. If you take a look at this residual plot, you notice that we have a pattern that is curved. And I'd like to address this line right here. This line is exactly this line, right? The least squares regression line, because that has a residual of 0. Remember, residual is that vertical distance from the actual and the predicted. The least squares regression line, that is our prediction. And so each one of these years is the residual, which is on our y-axis, is plotted here. So when you look at a residual plot, if you start to see a pattern, then you know that the least squares regression line is not a good fit for that data. So let's take a look at an example that would be, right? So here is a scatter plot of the Ford F-150, and we did talk about this in lesson 2.5. And this is, on the right is the residual plot. So let's take a look at the scatter plot as the miles driven. So as there's more miles on a truck, the price of the vehicle is dropping. That makes sense. And our least squares regression line is drawn in as such. So if we start to look at the residuals, right, the distance from that line, and we plot the residuals on this residual plot, we start to notice that there is no pattern with our data at all. In fact, it's pretty scattered. Some of them are above, some of them are below. And if that happens in our residual plot, then this line is a pretty good prediction to find the price of that truck with the miles driven. But how good is that line? Well, we can use the coefficient of determination, which is called R squared, to measure how well that regression line makes predictions. So R squared measures the percent of variability in the response variable that is accounted for by the least squares regression line. All right, so let's take a look at an example. So below is the least squares regression line model to look at the price that was driven with 41 Dodge Chargers. So here are the miles driven on these Dodge Chargers as well as the price on the y-axis. All of those 41 Dodge Chargers are plotted on our scatter plot, and we have the least squares regression line. So we're going to interpret the value of R squared and it equals 67% of, for this model. So when you interpret the value of R squared, and it is at 67%, that 67% tells us that it is 60% of the variability in the price of the Dodge Charger is accounted for by the least squares regression line, with X as your miles driven. So 67% of the variability in the price of the Dodge Charger is accounted for by the least squares regression line. I hope you guys are having an awesome day, and I will see you next time. Bye.